Here we're given 3 points, P, Q, and R. They have the ordered pair XY equals -1, -4 for P, 1, 1 for Q, 4, 2 for R. And they live on a flat plane. Now, you're asked to find another point S, which will be represented by the ordered pair XY, such that when you connect these points together, P, Q, R, S, it forms a parallelogram. Now, the first thing I did, I wrote SLU, and I started the sketch, the y coordinate, the x coordinate, and then I drew the points in the approximate locations, P, Q, R. And then to come up with the value for S, I remembered that a parallelogram, opposite sides are parallel to one another, so I estimated S to be located where I drew it, and it has the ordered pair XY. Now, the next thing I want to notice is there's a special configuration of the lines, the interior lines segments that join the points together. For instance, the point P to R, or R to P, that cuts right through the point Q to S, and they cut each other in half. So the distance from P to the middle is the same as the distance from the middle to R. The distance from Q to the middle is the same as the distance from the middle to S. And then I noted that if the diagonals, and those are the things that I just drew, if they have the same midpoint, which clearly they do in the sketch, then they would cut each other perfectly in half. In other words, they would bisect each other. In that situation, if I knew that they cut each other directly in half, then I would know that PQRS actually forms a parallelogram. So that actually tells me what I'm going to have to prove here. I need to show that the midpoint from point P to R is equal to the midpoint from point Q to S. Now remember the formula for the midpoint. Sum up the x coordinates divided by 2, that's the x coordinate. Sum up the y coordinates and divide by 2. That represents the midpoint from P to R. And then from Q to S, we do the same thing. We add up x plus 1 divide by 2, y plus 1 divide by 2. Now just a second. You see what I'm doing here? I'm looking at each of the points, and I'm using the x coordinates and the y coordinates in the formula. Now we need to simplify. We get 3/2, -1 for the midpoint from P to R equals, it has to be equal to, the midpoint x plus 1 over 2, y plus 1 over 2. All right, now, since the x coordinates have to be equal to each other, I can set the x coordinate in each of these two ordered pairs equal to each other. So I'll take the one on the right, that's x plus 1 over 2, and set it equal to 3/2. X plus 1 over 2 divided by 2 equals 3 over 2. Now let's solve for x. Get rid of the 2 by multiplying both sides by the LCD, then the 2's will cancel out. I'm using the parenthesis x plus 1, parenthesis 3. And when the 2's cancel on the bottom, I'm left with x plus 1 equals 3. And then I move the 1 over. I get x equals 2. Great, that gave me an x coordinate. Also notice that above, the y coordinates have to be equal to each other. So the y plus 1 over 2, the y coordinate on the right has to equal to -1, the y coordinate on the left. Okay, so let's solve this equation for y. Multiply both sides by the LCD 2. It cancels on the left. It doesn't cancel on the right. We get y equals -3. The conclusion is that the location of S, which had the coordinates x, y, has the coordinates x, y that we just located, that we just calculated. It's 2, -3. So we've answered the question. We found the point S such that PQRS forms a parallelogram.